Hello everyone, welcome back to my YouTube channel. Today in this video we will be diving into financial mathematics, which is an interesting topic in mathematics, well, particularly in finance, I would say. Well, so now, what is financial mathematics actually? Well, financial mathematics is a field that combines mathematical methods with financial theory to solve problems in finance. It is the foundation of many financial practices, from calculating interest rates on loans to determining the value of complex financial instruments. Okay, for the purpose of this video, we'll be focusing on interest rates, specifically simple and compound interest, and how to convert from nominal to effective interest rates. So now let's start by the simple interest. Well, the essential feature of simple interest is that interest, once it accumulates over time, it does not itself earn further interest. So, for example, you deposit an amount, a certain amount, in your bank account for a particular period, maybe let's say 2 years. Well, for first year, you that deposit would earn an interest, right? So in the following year, that interest that you have earned, it will not earn further interest. So that's what it means by the simple interest. So now suppose that we have the amount deposited. So we'll denote that amount deposited, or we usually call it a principal amount. So we denote it by P. So that will be the principal amount. The principal amount, and then we have okay, the principal amount, P will denote the principal amount that pays a simple rate of what, of I. So this will be the simple rate. Simple, actually it is the simple interest rate, which is per annum, and then N will denote what? N will denote the number of years. So now the accumulated value of our deposit after n years, we will use this formula to calculate the accumulated value after n years. So now the accumulated value will be equals to what? Will be equals to the deposit amount, or the amount deposited, into 1 plus ni. So we use this formula to calculate the accumulated value of our deposited amount using the simple interest. Same applies to depreciation. When we depreciate using a simple method, so this is for depreciation, we are going to say, okay, the depreciated amount after n years, will denote it by D, will be equals to what? Will be equals to C into 1 minus Ni. So C will be our what? Will be the cost of whatever will be depreciating. Then N, it will be what? Number of years. Then I will be our depreciation rate. So this is for the simple method. So now here I have example of calculating the accumulated amount using a simple interest. So now they're saying you invest 1,000 into savings account that pays a simple interest of 5% per year if you leave your money in your account for 3 years. So basically we have a P of what? P of 1,000 rands, I of what? Of 5%, which is equivalent to 0.05 in decimal form. Then we have N of 3 years. Then the accumulated amount after 3 years, it will be 1,000 into 1 plus, what is our N? 3 into 0.05, which is equals to, so now if we calculate it, 1 plus 3 into 0.05. So now if we calculate it, then it will be 1150. So this 1150, it will be our accumulated amount after 3 years. So if you have to calculate interest will be the accumulated amount minus the principal amount or the initial amount. So it will be 1150 minus 1000, which will be what? 150. So the interest that we have earned over the period of 3 years, it is equal to what? 150 rands. This is for simple interest. Now moving on to the compound interest. Well, for the compound interest, what you have to know is that the essential feature of the compound interest is that the interest itself earns interest over a particular period of time. So now, for example, for your deposit, maybe let's say you have deposited your certain amount for 2 years. Now for the first year, your deposit will earn interest at whatever rate you pay offered. So now, after earning that interest, well, in the next financial year, that interest that you have earned in the first year, it will also earn interest in the second year. So that's what they mean by the compound interest. So now for the compound interest, well, in order to calculate the accumulated amount after n years, using the compound interest, we use this formula. We say the accumulated amount equals to P, which is the initial amount, into 1 plus I, which is the compound interest rate, then to the power of what? To the power of n. So we use this formula to calculate our accumulated amount for the compound interest. For depreciation, well, we have this method called the reducing method. So now it means the depreciated amount will be equals to what? It will be equals to the cost into 1 minus the depreciation rate to the power of what? To the power of n. So that's how you calculate the depreciated amount using the reducing method, or it is called, they usually call it the reducing balance method in accounting. So yeah, we have this example. We are using the same amount and also the same rate, but then this one it's compounded annually, not simple interest. So now we are depositing 1000 rands into account that pays 5% compounded annually for 3 years. So now, in order to calculate the accumulated amount after 3 years, we are going to say A equals to P1 plus I n. So it's 1000 into 1 plus 0.05 to the power of what? 3. So now this will give us, okay, let me calculate it. So now it gives us 1157.63. So now if you compare the two using compound and also simple interest, you notice that if you use the compound interest, well, for compound interest, always the accumulated amount will always be greater than the one for the simple interest. What's the reason for that? Well, the reason is for the compound interest, well, we said interest itself earns interest, unlike simple interest. Well, for simple interest, well, the interest that you have earned, maybe let's say for the first year, it will never earn interest in the second year. So that's why this amount, it is what? It is less than this amount for the compound interest. Okay, so that's it for the compound and also simple interest. Well, moving on to the effective interest rate. So effective interest rate, we usually call it the compound effective interest rate. Well, The effective rates are compound rates that have interest paid per unit time, either at the end of the year, or I would say at the end of the period, or at the beginning of the period. So now effective rates are the ones that we use to calculate the interest. So sometimes interest rates are quoted as nominal rates, which do not take compounding into account. So what you have to do is you will have to convert the nominal rate to an effective interest rate, which reflects the interest earned or paid. Now, in order to convert a nominal rate to effective rate, we use this formula whereby we say 1 plus I effective equals to 1 plus IP over P all over to the power of what? P. Whereby IP, it is our what? It is our nominal rate. Nominal rate. And P, it is the number of compounding periods. For example, let's say you are given a nominal rate of 4%, and they say that nominal rate, it is compounded quarterly. It means our P will be equals to what? It will be equals to 4, and then our I to the power of 4 will be equals to what? It will be equals to 0.04. This is our nominal rate. This is the number of compounding period. So let's look at this example of how we can convert the nominal into the effective interest rate. So like as we are saying, suppose you are offered a nominal interest rate of 12% per year, compounded quarterly. Now, in order to find the effective interest rate, we are going to use 1 plus I effective, which is equals to 1 plus I to the power of P over P to the power of P. Sure. So now what is our nominal rate here? They are saying it is 12% and it is compounded quarterly. It means this will be I4, which is equals to what? 0.12. And what is our compounding period? They are saying it's compounded quarterly, right? So it means our compounding period, which is P, it is equals to what? 4. Therefore, 1 plus I effective equals to 1 plus 0.12 over 4 to the power of what? 4. Now, in order to calculate the effective rate, you are going to say effective rate equals to 1 plus 0.12 over 4 to the power of 4 minus 1, which gives us 1 plus 0.12 divided by 4 to the power of 4 minus 1. So that gives us 0.125509, which is equivalent to what? Which is equivalent to 12.5509%. So that is our effective interest rate. So now here's a tip. Always when you calculate or when you convert from the nominal to effective interest rate, well, your effective interest rate will always be greater than your nominal rate. So we're given a nominal rate of 12%. Now check what is our effective rate. It is 12.5%. So now always your effective rate will be greater than what? Will be greater than nominal rate. The reason why it is because the effective rate take into account a compounding of our interest, while the nominal does not. So that's why the effective rate it is greater than what? The nominal. So yeah, that's it for this video. Thanks for watching, and I hope this explanation helps you understand interest rates a lot better. In my next video, we'll dive into some application questions based on interest rate. So stay tuned for that.